this is China's Math Olympiad problem 1, which is always the easiest. Alright, so AN is a geometric sequence with the 9th term 13, the 13th term 1. What is the first term as a base? Log 13. Alright, so yeah, this should be easy, and try it out, and when you're ready, let's go to the solution. Now, of course, this is about geometric sequence. We need to know the formula, right? So if the common ratio is a q, then the nth term is going to be the first term times q to n minus 1's power, right? So we're given two values. Let's plug them in. Yeah, the 9th term is going to be 8's power. The 13th term is going to be 12's power. What we need is we try to find log with a1 as a base and 13. So we have two unknowns, two equations. Looks like we can solve for a1 and q. All right. However, you don't necessarily need to solve, the values. Let's observe that 8 and 12, right? So the difference is 4. Looks like everyone is multiple of 4. So let's do that. Let's divide this equation. I call this 1, I call this 2. If you divide 1, right, divide 2 by 1, what you get is the left hand side, a1 cancels. You're going to have q to the 4th power. You're going to equal 1 over 13. Of course, notice that here it is something related to 13. So I'm going to, because we're dealing with logarithm, so I'm going to write in the power form. It's 13 negative 1's power, right? Which is the same thing. Now what? We know q to the 4th power, but what about a1? Here again, you don't have to solve for q, and you're going to plug that into either one, right? Either the first one or the second one. You're going to notice that q can give you q to the 12th power, right? Which is q4 to the 3rd power, right? So let's use equation 2. Rewrite equation 2, right? Equation 2. Here is a1. Here q to the 12th power is equal to q to the 4th power and raised to the 3rd power. Earlier, we know that this is a1. This is 13. Yeah, negative 1, and then 3rd power would be negative 3, right? So that equal to 1. So what is a1? In the a1, of course, is equal 13 raised to the 3rd power. Again, you don't have to calculate the actual, what is 13 times 13 times 13. You don't have to. Why? Because we are dealing with logarithm, right? And so let's try that. By definition of logarithm, yeah, we need to recall what is the definition of logarithm. Okay, so let's recap what we have so far. Yeah, so we have this one, yeah, by the two equations, right? And then you plug in, to the second equation here, you get this one. Yeah, so now we are looking for logarithm of base a1 of 13. So if this is x, the definition of the logarithm is that a1 raised to the x power is equal 13. So here we know that a1 equals 13 to the 3rd power. So how to have 13 and when you raise to some power? So this is 1/3 of power, right? a1 1/3 power, x equal 1/3. Yeah, because from here you're gonna have this. Okay, so again, this is just by definition of logarithm, right? So that's the solution, which is 1/3. So a few things we learned is that sometimes you don't have to solve the actual value. You want to find out what's your final objective, right? So in this case, you don't have to multiply 13 by 13 by 13. Rather, you're going to, have this in the proper form for the logarithm. All right. So hope you enjoyed the video. Please like, share, and subscribe. Also, leave comments below if you would like to cover any specific problem or topics. Thank you.